Good morning, or whatever it is, wherever you are. All right, so there's still things I want to do with the GUI here. I just kind of want to get off that at some point and on to seeing if we can get a higher level of detail. However, one thing that has been bugging me. I don't know if it'll show up well here. The thing is that ever since I subclassed this, it started changing the default to local time, which I don't mind. Maybe I did that. But we're defaulting to the 1 second, 1 frame per second, which is just going to annoy me every time I use it. So that needs to get changed back before we start doing a branch. Oh, so I must actually be sending something over. But that doesn't make sense. Now you see transition time, 100. That should be 10 frames per second. This is 1 frame per second. And this is just unconfigured. Because my speed step is 1. Time dimension control options. Has the subclass removed all options? No, not all options. So why is it ignoring all the rest of this stuff? Oh, we lost that too. Yeah, so it's ignoring most of these. And that happened when we did this. Yeah. Oh, you know what? You know what? I was lazy. So we have, probably need to check all of these now. So this needs to be I think it's a call. The current object. There we go. Okay, that was the only time we did that. But while we're there, I did kind of like I mean, well, for an international game, UTC kind of makes sense, but I usually put it in local time. Time dimension. No, we actually need the control. Time zones. So it's normally UTC local. We want to be local UTC. Nope. That does not control the sorting. Well, okay, so first of all, did I get this option right? Now, it is interesting that without this act, It didn't implement options, it probably didn't get options. And probably count as not present. Nope. Am I even naming this right? Time zones. Array of strings. Yeah, so it's completely ignoring that field. Is this a different version? One 110 110. Yeah, it does. Sorry, kid, it doesn't have that feature. Unless that's picked up by some sub-library. That's weird, because you think there would have to be at least something to... I mean, this button does something. So when we do all the create buttons, backward play, forward, loop, date. Get current time, get display date format. Date UTC to locale string. Yeah, that's not an array, that's just locale string. initialize date UTC true. Okay, so the only thing we could do and what's weird is that when I messed up the this on the on add, we still got all our buttons. Maybe it initialized a completely separate control? Alright, so that's not an easy thing to update. Notes did have... Yeah, I have got that as a note. No, you're the compiler. Okay, so that was just a comma. We don't need that. Fix. Initial time control settings. All right. Because you check out. All right, and that's going to have to get, well, that's a minor fix. That won't be a big deal if that doesn't have all the versions pushed. All right, so now we need a reference design because we have to emulate a very, very specific version of this. Or a very, very, very specific version of the fractal noise in order to emulate the base game. This might actually be some minor gem stuff. Yeah, fractal noise. Yeah, so what we really want to do get is, and I should get a little bit in Crucible. Well, okay, so that didn't sync up properly. Is to start getting this level and lower, which we don't really get lower right now. Now, all of this is generated by these XY fractals. Or there's like a density function and then some other stuff that determines which item you get. And since the biomes use the same XY fractal, we'll probably actually do biome generation first, just because it cuts out the need to save all of this stuff. You know, if Crucible ever comes back, we could have the entire map. Oops. We could, if we really wanted to, we could fill in all of these blank areas. Although that doesn't give you a sense of where people have been, but I eventually need something higher level because past, say, somewhere around here, this view is just not useful, other than some kind of visual consistency for moving around. But that is actually, looks like it is, well, it's probably minor gems. Yeah. So other than some parameters and usage information, we don't need that as much. We need to get something working first. Actually, I guess in order, well, there's some algorithms to do, but in order to get it working here, I'm going to need a custom draw layer. Let's see, so for the life data, particularly because it's animated, and we have to loop the data every time, I wanted to get it so it was drawing the entire screen. It's probably just as well to stay tiled on this, so our point overlay will be a reasonable starting point for how to draw or how to create a custom layer. Okay, we don't need to animate, we don't need to select points. There's gonna be a bunch of other stuff here. All right, color. Those are all color functions that are kind of used by this. Grid layer. This is, no, this will be the biome layer, but this is going to become like a fractal test layer. Grid layer extend, it's not going to override the pane. It's going to have a tile, it's going to have a tile size, it's going to have a canvas width. Okay, we instructed the draw function because we wanted to be able to redraw it. Having that abstracted is probably still fine. It's not going to be time dependent. We don't need, we might need some other things. Don't need time dimension. We do have to get tile size again. Don't need that. We are going to need some of these coordinates to know what our world coordinates is. Let's see, do we have any other coordinate translation stuff? No, it's just we've got our lat, our long. I might have to be doing a rect fill, but maybe there's a way to set a particular location. We don't need to update tiles, we don't need to select points. That was bigger than I thought. All right, so for proof of concept, lat long, north, west, and southeast. What is the syntax for a canvas rectangle? Is that from 1010? A size units. Well, since we have coordinate translation, oh, no, these are lat long. This, so we need the lat long for the generation. To fill it, and then context dot, is it fill style? And then we actually have to get this thing in there. So I guess we want to call this another base layer. Ooh. I might be able to do that. Let's see, base, base, base. But these won't exist yet. We're just going to call this a dummy for now. We didn't really make a function for this. Oh, map config. Oh, because we had URLs to the tiles. So you probably just get options. Oh, you don't get error tile URL. Now this one can actually doesn't have any. Well, for biomes, maybe. Now, this is going to have a native zoom. I don't think. This is going to be kind of sort of a raster layers. Oh yeah, I can do asynchronous processing. So tile size, opacity. Oh, it does have. Yeah, so we're not really gonna have any difference on native here. Well, I guess yeah, it would be just as well to stretch it. Yeah, base attribution will work. Init call init hooks is not a function. Okay, well, where is our point layer? Point overlay. It gets a class name. It's just a new. And then you get a different attribution class name and time dimension. We didn't really start up anything here. Let's cut out the actual code call, see if there's something more basic. Okay, so nothing there. Let's see if it doesn't like some of these options. Call init hooks. Is it because we're adding it to base after the other stuff? So this is 482. Fractal's at 93. So we should be fine. Okay, it's not specifically base layer. Does it matter? That we're putting it into one of those? No, it does not. Oh. Is it L grid layer? And it's just called grid layer. And implement the create tile method. So why is my point overlay fine and this is not fine? Okay, let's take all of this and then back pieces out until it breaks. What? Okay, I mean, that doesn't make sense, but why? What's different? Is it referencing some symbol? Okay, I never added it to anything, but that... What the heck? Well, it's not on the map. We must want to turn that into the default layer, but... Okay, we have something that will execute. Okay, no data, none of that. Clear rect, don't need padding. We're going to need all the coordinate translation, and pretty much everything down here is gone. And we don't need that, we don't need that. We shouldn't need that. Context.fillRec, context.fillStyle. Okay, it's not actually using this right now. I don't think any of the... any of these parameters matter, but it's going to function in a very similar way. All right, now why are we not drawing? Are we... Attempting to create tiles. Oop. Okay, well that we missed that. We are not attempting to... Oh. Wait, no, this is the actual one. Okay, well... Wait. Oh, gosh. You were supposed to be point layer, right? Let's update monument layer. You're fractal. Your color. How did we even make that? So that's in the wrong layer. Are we even calling you? Okay, we called the function. Oh. This is one of the problems with copying code. Right, it sees that as very similar. This is seeing all this is new. And all of this is added. I'm not seeing the removal of... Yeah, we totally messed this up. And you see, I didn't want to do a super crazy copy like that, or for an extended period of time, but it didn't work. All right, so before we start messing with color stuff, fractal layer, and I need to get this as different as possible as soon as possible so we don't mess this up again. All right, no syntax errors, no syntax errors. Base, fractal, new L dot in their style. We don't need that. Don't need that. That will kind of match what we've got. Doesn't draw anything yet. But then what the heck is it? Extend. New. Point overlay. What? Wait, we're missing something here. Fractal layer. Too many L's. And then we want to actually try and draw something. Okay, we have something that draws. Now, for testing purposes, see, none of you can get added to the map. So we add a map, base default. All right, now, I might actually want to do some sort of transparent overlapping with these, which case it wouldn't work as a base layer, but we just need to draw stuff right now. All right, we have a place where we can get output. And I haven't actually gone to... And was it here or was it the other one? At one point, or maybe I was executing all of this stuff. Well, probably a long lost build directory. But maybe I kept that around as mapping. No, because I had run the thing that dumped out the fractal at one point. And that we're going to have to get that comparison data at some point. What? Was it not called fractal? Oh, maybe it's common. Not... Ah, it's common, not minor gems common. Fractal noise. All right. So there is some math functions here. We might need to hope there's... So we have a set seed. JavaScript has bit operations. Although this is... Original XX hash algorithm is found here. Random numbers testing. There are moving lines that don't seem to matter for procedural content generation. Well, that explains some of the artifacting. All right, so get XY fractal. So we have random BN, which I suppose it uses tweaked hash 2D. Get XY random is tweaked hash 2G. Okay. With a multiplier. All right, so we need some base functions. Oh, because that's whole word. All right. I need common source. All right, so fractal generation copying which cites no. Copy this one, please. Now, I'm actually kind of curious to see if there's like some test programs. C# procedural generation. So it was already more modified with more procedural generation. Repeatable random numbers. Randomness based on these tests. Oh, so this calculates their randomness. So was the code in assets? Or hash functions, random number generators. Well, the hash function would be in there. Value, range. XX hash. Wow, this is already way back. Okay, so what was the test code? Testing. Yeah, so this is testing randomness. It's not really going to do any consistency stuff. All right, so our lowest level thing is, well, we're going to have a seed, we're going to have values, we're going to have a hash 2D. That's even to take 2 int arguments. Original, they take 2 int arguments that don't seem to matter. But we want to implement this algorithm. So this is our first target function. Are these not directly exposed? Get XY random. But this algorithm is using this directly. So we could probably infer something from here. But I probably want to get as close as possible to this code. So I may have to tweak expose this. So actually, I probably... So our mapping program right now is a modified client. Well, we could still have it call this and print a couple numbers. All right, well, we can implement some stuff here. Have something to test against. All right, so it's going to have a seed value. It's going to have some constants. I'm a bit worried about JavaScript's floating point math trying to reimplement this. So these were defines. Actually, rotate left is the thing he took out, isn't it? Yeah. All right. So we have an intermediate value that we are doing lots of stuff to. Yeah, isn't there another stuff that compiles JavaScript to C? Which would be one way to do this. I always forget which languages have which operators. Okay, so it is a plus equals. Times equals. Now, is that operator going to be the same? Because I'm pretty sure that's an XOR in C. Okay. So as long as we have, see, x is 2. As long as we have, oh, do we have this? Yes. That's kind of like sort of the top with the bottom. That also kind of removes prime 4 from the picture. All right, does that have syntax errors? That has a syntax error. '96. Oh, U is not a U is not a thing here. Okay, we are past the syntax errors. So this by itself is just a straight up 2D hash. So that gives us a 32-bit number. Now I had actually color map, well, it scrambles it. But toString 16 kind of gets the essence of it. Actually, maybe for numbers, I would want to do this more as a grayscale. Because I think this is just going to be noise because it's a hash function. And this is where we need to look up individual pixel plotting. That might be image data. Basic usage. This might be too basic. So we could definitely fill rect. But is there a thing that's optimized for single pixels? Path 2D, SVG paths. Pixel manipulation. The image data object indeed. RGBA. Okay, so if you want to deal with pixels, we've got to do all the image math. Get color indices for coord, which gets a whole set of things. So the easiest way is actually going to be to, well, pick one dimension or image data, index, index, index. Oh no, that gives the indexes for that. And then uses destructuring from the newer stuff. To create a new blank image data, same dimensions, but how then do we set that into a context? We're just assuming an image data here. Copy of painting data. Put image data. Grayscaling and inverting colors. Saving images. So this is an image data. Well, okay, so we've got examples that are updating a thing, right? It's the color picker. Invert, put image data, blah, 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 blah. We're really creating this from scratch. So we could, We don't need to get image data necessarily. Create image data. So context, we've got a context. Oh, that's from another image data. New blank. Width height is tile size. Oh, we've also got a tile width, tile height. All right, so we've got a data. I guess one thing we could do with this, present our transparent black. Well, we definitely need to set this back. Put image data. And then everything else we do is going to be in there. So so datas have a length. And we can go pixel by pixel by going by 4s. Data, and it is actual integer. So let's just go half, except this is +4. That should get us, well, the default image is grayscale, so that's actually not very informative. Let's just create our red again. Data, oh, that's right. I used the shorter version. Pardon? Okay, that did not do what we wanted. Oh, well, yeah, because so you have to actually change the coordinates. And just to keep everything even. Okay. So we were drawing before. Oh. Is length 0? Oh, okay. Sure. Oh, for every tile. But its length is undefined, so I don't know where they're getting... Oh, wait. There's the image data object. The data, which is the array in the object, and a image data object has the width and the height information for its contained contents. Right, okay, so image data, sure. We don't need to do a lot of manipulation on that. There we go. So we can write stuff. Now, can we write something more interesting? So we've got an x and a y. We need to format this so it's an actual x and an actual y. So these are going to be lat long coordinates. So either I iterate over the tile figuring out how to translate that to the coordinates. Now, if that's a lat long, it's probably going to be like Latin long. I've point overlay. Yep, lat long dot long and lat. Oh, are these going to be one-to-one? Because at some scale, our pixels... We're not, I mean, as you zoom out, it's not a pixel to one lat long step relationship anymore. So we, So what we were doing before was getting the bounds. Well, based on tile size, what I did before in the mapper so is this the stride? Oh, tile size is always 256. That never changes. I need to know, well, chords has a Z, right? Yeah, so we've got a zoom level. I mean, I guess I could just do, we could start with just the XY within the tile. Just to see something. We do kind of have to get this working at some point. Tile size. So from the zoom level, a whole map. This is the base one. I want to go into mapping. Oh no, this is the execution directory. The source is still here. Map.cpp. dump. Biome image. Output map biome image. So this gets a stride from outside. So we're probably looking at game source. I think we're still in living life page. Biome image. Stride is right, because we're only dealing with one-to-one right now. So this would get weird if we go beyond 24. All right, so draw tile. We need a we need fractal, not point. Oh, I just never get rid of padding this time. So we need so for this I might only need one of the corners. Stride equals. Do you have? I think it's just math.pow. 2 to the 24 minus chords dot z. So we've got northwest and southeast. So I was just kind of thinking my way through that before. Biome image. So that's our 256. So we have a start X, start Y. And then we just go each and then use this stride as our increment. So this is going in pixel space, which is fine. But we're going to have to then calculate well, that means we could get, you could calculate I back to the coordinate as well. And it's kind of 601 half times the other. We're going to want our coordinates anyway for the actual map stuff. And then height. Yeah, so this is pixel space. And then for this, we have to calculate, actually, well, that's setting an entire color. Y times, actually, I'm going to be referencing these a lot in this loop. y times width. Yeah, so that's our index that's our pixel index. All right, so first little sort of smoke test here. Does this fill our entire image? We haven't used stride yet, but that's to deal with. Nope, padding is not. Oh, right. I actually expanded my coordinates because I was using that for bounds. Fractal error, so we don't need to do that here. Because the points can be a little bit bigger, and even the eve circles can be even bigger than that. So that was actually throwing off our corners a little bit. Okay, so we can fill the entire image iterating in that manner. I guess for parity with our other thing. Now for this, I don't think I need both corners. I need I use origin for anything? Oh. So I'm using that to translate back to the canvas. So is that what I need? Oh, right, I had to separate that from here. So that is the point northwest. Is that what I need? That is how a canvas image is coordinated. But if I want to match the game, we have to be doing our x, y's. I'm going to have to invert something somewhere. So that has to do with translations. I think we have the 0, 0 location and the 0, 0 tile. The game coordinate system says the 0 tiles are, or it's geographic, or geometric. Positive x and y are that way. Leaflet is computer graphics centric, and it says positive x and y are this way. So I'm drawing a tile in canvas space. Well, Actually, this is a canvas. Isn't canvas geometric as well? Or did I have to purposefully do that? Well, here we go. Because it doesn't tell us where the boundaries are. And like, we could just draw part of it. It doesn't tell us what the top or the bottom is, though. Well, what if we did both of them? We still don't have a basis. Well, we've got gradical. So we know where 0, 0 is. So actually that... Oh, because the tiling system is the same. But where they do line up... That's not even a... Right, because that's powers of 2. But that tells us that the canvas drawing is itself that way. Now you can actually invert the canvas coordinate system. And I've done that before. You just do a scale negative y. But I still have a point northwest. For game mapping purposes, I kind of need... so actually I don't need origin here because we're just doing the offset xy. To be a comparison to my biome function, I kind of need point southwest. But then the question is the xy our image location? Okay, this is looking like we're actually doing minus y here. When we calculate the world coordinates, start y plus h minus 1 minus y. So that might be doing that same kind of translation. It's because we're doing image coordinates and they want to go down as well. All right, so that is u. And we won't actually be able to test this translation system until we get other things going. I guess we could do some coordinate stuff. So wx is, well, start x. So if we're inverting that, so we're probably tiling in world coordinates. So we're going to have one point that's our start point. And if this has to get inverted. So if we go to 0, 0, and this is tile 0, 0, we're going to translate that all down to 0. And if our start y is 0 plus height minus y is traveling up from the bottom. World x. What's our start x? So these will overflow a lot, but near the origin they might work. Right. So what we need is, we could try point northwest. Point northwest dot launch. It's a whole lot of black. Don't necessarily need that anymore. For relative coordinates, we actually kind of need this. Okay, so yeah, as we approach, then we overflow. But for world coordinates on the scale of 256, this is, it's viewing this, well, no, yeah, this is world coordinate 0, 0, increasing, increasing, increasing in x, increasing in y, increasing in both. Okay. So I don't think we actually need southeast then. Let's get all of our calculation stuff kind of together. All right, so we've got our input coordinates, and we're really only going to have one dimension right now. XX tweak hash 2D WX WY. Okay. Are we bothering to return something? All right, so this is where the languages might clash just a little bit. Okay, lots and lots of in fact zeros. So let's do something a little bit more limited. And figure out what the heck is going on here. First of all, we have arguments. Second of all, we have okay, we don't have a seed. But I think 0 is still a valid seed. So we've got step A, where really all we have is H32. RB, where are we? Oh, if that's a shift down versus a shift rotate, that might be a very significant detail. And we're straight into NANs. Well, arg is NAN, so that's a problem. Which is weird because Oh, I did point northwest. That explains a lot. Okay, I don't... Right, they're 0.5s because we were doing the center. Shoot. That was good for drawing points. But I need to know which way I'm offsetting these. CRS. Plus 0.5x and minus 0.5y. Well, if we put in... I'm going to have to get to a point where I can actually see 0, 0 on here. Actually, one of these should actually be the tile for 0, 0, right? There's negative 0.5, so it's going to need to add 0. So it's going to be in this direction. Probably need like a debug toggle for this or something. All right, let's all the same expand this a little slowly. Well, it's white, but it has a faded edge. That could be some weirdness with starting at 0. Yeah, okay, so this is not doing great work right now. Although this is probably a larger space than 256, which I really should have thought of. Okay, so yeah, are we getting worldwide variation here? Okay, well, it seems to break down at a certain point. This might be floating point precision. So if I zoom in on that black area... No, that's not good. Now, this is just a hash. This gets put into other functions to do stuff, but... if it completely breaks down at distance, that's gonna be problems for us. Okay, doesn't completely break down there. That does. Interesting. So maybe it's the stride argument messing with it. Well, it could be pushing it beyond floating point precision. There's a little bit of really dark noise out there. Well, or maybe we're getting like dark light patterns, not full gray gamut, which could be the loss of precision with floating point. Now, isn't there... floating point representation is more than enough to perform exact calculations in 32-bit integers. Oh, they're counting on like 32-bit overflow and stuff. Number type. So plus plus. Yes, they're probably counting on some wraparound. And as annoying as that is, in order to get exact results, we have to account for that. Now, some of these multiplies could get quite nasty. Also, is that... Did I miss the multiply there? Or is that actually adding that? Plus, plus, times not, times not, times not. So this is where I'm probably going to have to put a number through both with a bunch of debugging. And then particularly try some large numbers to see if that's causing us trouble. All right, fractal noise.h. Oh, it said it was static, so we have to... remove that. Where is... Oh, the main program is actually in minor gems, isn't it? So our earliest entry point is game.cpp, I think. It's been a while. I really don't want to be doing any of their stuff here. Maybe it's actually at the bottom. No, there's draw string. I know I went looking for the entry point before. So I had it at one point. Looks like a big function. This might be the update function though. Draw frame. Where do you get called? You don't get called by this. Do you get an init function? Oh, maybe it's game page. But like what says create a game page? No, this isn't even game page, yeah. This is like a lot of initialization stuff. Init frame drawer. Drawer. No. Init draw string. I guess it's init frame drawer? I mean, unless there's like a onelife.cpp? No. I think game is kind of it. Okay, well, it considers this pretty early. Now, you don't directly include the fractal stuff right now. Shoot. Which is the syntax? Local, local, local. Except your common source? You are game source, so it's going to be the same relevance, relativity. Actually, applog is already print out next message. I kind of need something I can print anywhere. So unfortunately, it's going to go to the other log. Because what I really want to do is to get into fractal. And just call XX. And I kind of want to check every. Actually, it's +4. Every little step here. So I guess this would be A. B. C. D. E. F for final. Is that going to be stand.io? And then we forgot some semicolons. And then you can exit. Oop, more semicolons. Offsite, one life, game source. I might have to clean up some files here from other dependencies. Yep. Needed by RM. Actually, we should probably just make clean. I can't do make clean because it's stuck there. And that's the infamous space. So we've got two modifiers. Well, they're both in the editor. No, don't load file. And that took out the make file. And 32. Not declared in this scope. That's why I put it in the header file. But fine, if you want to be a little jerk. Oh, the header file wasn't in my buffer. This actually works just as well after removing it from the static. All right. Doesn't matter much where we execute this. Might want to be somewhere where we've got stuff. I guess mapping is probably fine. I don't actually call it mapping. D games, one life. Need to update this sometime. And do a CD. Oh, I can't. No, games. And all right, so mapping output. We might be doing some live updates on you. Okay, so that's 0, 0. Let's I might need to back off and do like a more of a test suite type thing where you like throw a bunch of, make a list of numbers and throw it at, I mean, it could be a pretty arbitrary list of numbers. Except I would have to like, I guess I'd write to a specific file that would dump this and then read it into the other one. Okay, so the arg is always 0, 0. Oh, you might have been seeded. I need to know what our seed is. To get comparable results. Okay, seed 0. We should be the same there. So we start off good, and we'll try this with larger numbers. Yeah, and then we have to check every option for every operation for integer overflow. Okay, I just moved it over here. Oh. I might need to, if it getting the overflow. So there are possible shims. Oh, that's right. I remember seeing these tricks before. Signed 32-bit integer, unsigned. Should be a different question. Does not handle overflow correctly. For multiplication, we also have some addition, so that's interesting. Does this have any further comments on math operations? Math. Oh. There's... Apparently they've added a bunch of functions. What is the hardware concurrency? I don't think it had anything to do with that. Well, no compatibility table there. Well, this is an ES5X. Oh, now it's got ES6 shims. Properties. So this was ES5, and now it's just kind of kept on going. All right, let's see how much imol does for us. And we'll have to look into a shim if that proves to be useful. Okay, that is definitely not the same answer. That's why I had this over. All right, 37, 37. We got one more step. So operation D is... depending how they're doing the sign change might actually be responsible here. Okay, so we have a bit shift and a not. So we have to break that down to make sure we understand what's going on. Oh, we don't. We have okay. We have the value before. But we don't. We have to do it here. All right. So that gets you. H32 13. Okay, so downshift not working so great. Where'd my there we go. So this is where we need to understand exactly what each of these think they're doing here. All right, so actually I should be putting these out in hex. Because ultimately that's what we care about. Now, well, that wouldn't work if we did end up with a floating point number. But so far we haven't. How... Is it like 0 point? These are 32 bits. 4 bytes. 0.8? Let's see if that looks about right. One, two, three, four, five, six, seven, eight. Okay, maybe. So we want substitute one character with 0.8x. I could have searched to replace this. All right, so now we can look exactly at... Oh, this doesn't tell us when it's negative. Which might be significant. All right, and now this might be more awkward here. I think it's toString 16. Now this doesn't necessarily get... That's 16 bits. Reaches a given length. Well, that's just annoying enough. Pad start out to 8 with 0. Yes, no, no, yes. We'll have to fix that later. No, yes, no, no, yes. No, no, yes. Doesn't tell us bit patterns. Okay. This might not be in any way, shape, or form usable. So with two's complement, that might be right-ish. What do we do with you? I'm actually not sure that's right. Actually, isn't it like ends up being like negative +1 or something? How are we still getting negatives? Okay, that takes care of that, but I don't trust that to be the right numbers. Wow, that's like... I'd swear that this was actually the same number. I mean, it is just an arbitrary negative. So I could see the bit patterns being different. Decimal value. Yeah, so the conversion converting to 2's complement registration. Additive inverse. Decimal number 5. Convert it to -5. The bits are inverted. 1 is added. Inverting the bits of -5 and add 1. So XOR. I have no idea what the precedence of that is. And it still looks nothing like this number. But when I printed them as decimals, I'm pretty sure that we were the same up until there. All right, well, this is returning strings, so we actually have a little bit of a hook in this one, where we can say more complicated and annoying is going to be here. We have to go %d, 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 and then double everything. So for most of these, we just need to update this and then go F, E, D, B. H32, H32, H32. Zero flag. Oh, I hadn't noticed that before. Maybe it's just 8? All right. So we're getting this number correct. And we cannot get this representation of it. Let's put this back to calculator. So decimal. Five, 2, 1. Okay, it doesn't recognize the negative here. Ah, there we go. Unfortunately, we've actually lost the data. To 67278. I have 21. Okay, D word. Okay, that is a different hex representation than both of them? Interesting enough, the quad word did 1, 2, wait. Negative 1, 2, 6, 7, 2, 7, 8, 5, 2, 1. Okay, so there's your B4. I think this is it without the sign bit. Oh, so I have to do the inversion. Oh no, if it was just adding a bit, then the rest of this would be there. Can I have a second instance, please? So I just have to write everything down. D word. For B8, 9, 2, 2, B9 is that wait. Oh, right. When I just do it as 216, it's still negative. So that's giving me the binary representation of the positive number. So I guess you just have to know that it was negative. How do I get the binary representation of the not negative number? Wait, didn't I try this? Well, no, that's the positive number. It's doing exactly the same thing as the other one. So it's negative x. It's not f, it's 8. I guess the negative really matters here. What? What? Well, I mean, we're adding a negative and then removing it? Oh my gosh. What even is going on here? If it's negative, maybe we need to take the positive version. We might need to do a +1 here somewhere. And it still manages to be negative. So this is always going to interpret that top bit as negative. Which means this actually can't represent something that's not a 32-bit signed. Oh, I'm only. What if it was 64? And I'm not doing enough. Well, that cleared the sign bit at least. What if we didn't do that? Nope, still negative. But we specifically want that bit if it was negative. So what I'm getting from this is we can't use toString. How about could we do what if we did, what would that have to be? X and does that look right? And then really just still negative. That's no, it's 16. But it's still negative. For because it's actually losing the information. So we would have to do CB89 doesn't sound right. No. Right, because we actually have to be doing 2's complement stuff. But now we should be beyond the range where, oops, that's not going to work out so well. Where it will hopefully be not interpreting that as sign bit. All right, so we have to do first part. Negative x 16 toString plus x and toString. Oh, this is going to give me an extra. Well, if it's 0, it'll just be a 0 hanging out there. Other bits won't be there. We're going to pad it with zeros anyway. Or I could pad them individually to 4. Wait. Okay, I missed a thing there. B476DD47. Okay. Secondary number is, that could be a 2's complement inverse. Or something weird. So we can check here. Do these numbers have any relationship to each other? Uh, 5A hex 5A 3B 6. Okay, that's only showing me as many as I've got. Can I actually say 0005? Nah. That would be useful. And, yeah, because now this one's going to have the FFF. And not going to be aligned. So do these patterns bear any relationship to each other? Wait. How are they displaying so different? Well, they have different granted they have different integer interpretation. So this is the 2's complement. Oh no. Oh, the 5 changed. So I was missing the prefix. 5 changed to a D. Okay. Yeah, so the way we work with signs is not good. So in C, a bit shift down operation will bit shift the sign bit out of position and make it not a sign bit. In JavaScript, it will fill the sign bit. I don't suppose there's an option for that. A non-negative, all non-zero bits. Well, what language is this? This is C. Okay, we understand that. We need JavaScript. Shifting zeros. Zero fill right shift. It's a different operator. Okay, so now for this one, do I care about that? Not sure. We're getting right examples, right operations so far. All right. So for the 0, 0 point, we're able to get precisely equal results. So I probably need to be checking some non-zero inputs, but we want to see if this affects, improves our precision any as we extend out here. Seems like we actually lost something there. Of course, I wasn't checking results with any X or Y inputs, so this seems to be strictly scaling with X. In Y, is IMOL possibly not doing what we want here? All right. Okay, so we got a V there. This is going to be a lot of work that would get very spammy. So let's just go ahead and go 1, 1. Actually, I might need to maintain a bit of a test case here. We don't actually need this. And this is you know what? This is handling happening per tile. Currently, I don't need that. I just need to test the function once. All right, for 1, 1. Oh, yeah, that Operation B did diddly squid there. So do we not have IMOL? Okay. All right, so Operation A is seed plus X plus a prime. Okay, 0, 0. There's our... Actually, that was our first one. Yeah, there's in Y. Oh, that was a simple typo. Final result checks out. So are we still having issues at range? That looks like a hash function. Doesn't seem to break down at distance. Now, there's clearly some periodicity. Well, we're just striding at range, but it does seem to have some periodicity to it. But I guess the point of a hash is to reduce the space of things. It feels like there's a lot of extremes in there. In the Moyer patterns, though. I can tell there's some gradients. So actually that leaves me curious. Obviously, these results won't match, but... Don't know what that was about. Oh, and this was the whole rotate left thing, which is probably why he pulled it out. Oh, yeah, and the XY was a little arbitrarily put in here, I guess. I'm just curious how big a difference this makes. So the rotate might actually be a bit of trouble here. So it's down one way, so it's left by count and right by 32 minus count. So it was +4 plus u re-equals the rotate left and it's just a times, so we could do h32 and then there was another bit shift in between. Okay, and then rotate left. Is h32. Was there a sign extension this way too? Okay, nope. There's only one operation there. So we have to hope it's the same. This could have been totally pre-calculated, but that would be math. All right, so without necessarily checking to see if this is right, okay, so we still have patterns at scale. And we still don't, it still seems a lot of really black and really white stuff. So So that is a hash function, which is going to be an important piece of the puzzle. It's not the entire puzzle, but it's a piece of it. Uh, well, giving reasonable results, simple cases, match. I don't know if a hash function can be expected to be totally aperiodic. There are definitely some patterns. Okay. Fractal noise. So that gets us a lot of the really down and dirty stuff. So that is, there's some coordinate math we may have to work out. And then, okay, XY fractal has some more random stuff. And this is going to be harder to get like large scale comparisons on. Oh, and this is the one over int max again. XY random bounded. Interpolated for in x, in y that aren't integers. Oh! This is strict integer. He actually handled non-integer coordinates. So then we have to ask, you're getting doubles. Int in x. Oh, double reference, double in scale. Huh. Why do we need sub-integer precision on this? I mean, I get these are like floating point parameters. So we get the four corners. From the integer function. And blend in between. I mean, I guess it's cool that it can kind of go down infinitely like that. But if we're only asking for map locations, well, I guess it's this because we're doing different scales. So after all of the translation, we have to be able to get something in the middle of somewhere. Hmm. Equals function in y. So these are allowed to be floating point values. Laurent. I think we just have math dot floor and seal, right? Although, as pointed out, this is just +1. Well, depending on how your floor works. Hopefully floor is the right function here. Wait. Okay, you're assigning that to a double, but it's going to be an integerish value. And then offset x. Wait. Okay. Is that how you do it? 4-point blend? Well, we're trying to emulate this code, not get something that works similarly but different. Or maybe not exactly similar. And just see if anything blows up. Reference error index is not defined. I missed that one. X offset is not defined. Offset X. I was just, okay. Wait. Oh, no, this is right. Because everything else was like floor X. So you have to be X, right? Well, it's a number. Now, this is where, oh, no, this is not doing any of that stuff. This is just, if it's fractional coordinates, we want to estimate that. So we wouldn't actually use this directly, and we don't have fractional coordinates. So this is where we start to need parameters. Okay. Biome scale string, biome scale, biome offset, biome fractal roughness. Roughness in scale. Oh, actually, yeah, because that's by the number of biomes. In roughness, in scale. I guess that's to document the function signature. And then use this internally, or because it's how the found algorithm was. And it's going to be return. So 1 over int max. I don't need that constant yet. All right, is there a pattern to this? Well, it probably would be all inline. To reduce function call overhead anyway. So we do it at a bunch of different scales. And we are blending between the larger and smaller scale values. Oh, so actually, no, this is divided by, so this is going to be the little bits. This is some of the sub-precision. So divided by scale. So this is going to be the biggest blend. Huh. So for a small roughness value, it will mostly just be this. I guess that would make a very smooth thing. He divides that out, and then he has all the blending between the different integer coordinates. So a times I don't know if it's worth making variables for that. Yes, this would probably be loopable, except then that's looping code instead of just calling stuff. Plus b times all right, 32, 16, 8. Four, 2, 1. Oop, did I miscount? Looks like I miscounted. Thirty-two, 16, 8, 4, 2. And then the last one doesn't have any of that stuff. And we just have to close out you and you and you and you and you and you. Oh my gosh, this is too big to tell if I've got a matching brace. So I'll hop a little bit. Okay, so that looks like the last brace up there. One over int max. Wait. Isn't that the same as multiplying by int max? It's a double, though. All right, or is it multiplying? Yep, it's multiplying. So that is just... Yeah. Oh, wait. No, these are all doubles, so I don't need to worry about the imul. Similarly, this is going to be a double, so I don't need to worry about the imul. So I think this is going to try to give me a 0, 1. So approximate starting values, which this should probably be layer configuration, really. All right, so biome scale. For the real, I'm going to look up seed values too. So the default biome scale value. Oop, that's backwards. 83332. Biome offset is not 2. Or I typoed that in my default string. I'll have to that we'll have to compare against base code. All right, so you are actually going to be 0 to 1, we think. Is it fractal? No, it's folder. Get XY fractal. World X, world Y. These could probably be pulled out when we come to the looping as well. And we're really going to only have one scale. Biome scale, what is it, 7 biomes right now? Well, that's something. It seems to be something very wrong. How do you figure that out? Well, I probably have to go back to testing outputs of, well, larger values of the base function and various intermediate steps. And there's all kinds of room for numerical precision to be messing with us here. Although this type of pattern seems to suggest a pretty severe error. I find this particularly weird here. And the fact that, okay, it does, I don't know, why is it this line? Probably offsetting to a 0, 0 type of scenario. So it scrolls, but it doesn't zoom. Huh. Try something about the way I'm striding. Oh, I didn't have a scale variable in here already, did I? No, okay. Because I kind of refer to that with the zoom sometimes. Well, this is all blending among... Well, no, that thing does doubles, but all of its values would be based on ints. Yeah, so all our values are like black or white. You know, except for that little bit in there. Oh, nope, okay. They're mostly blackish and mostly whitish, but not strictly. This almost feels like it's maybe the blending function. What if we just did something? Okay, so we still have the striping. We did lose the diagonal, though. And A1 is the floor. Oh, but I guess if we're dividing the coordinates, that kind of makes sense. Oh, that might make sense. That would be all the floors. Well, that's not particularly any different. In X, in Y. It seems like I would have to be getting my X and Y confused somewhere. Like right there. I'd swear I searched and replaced that. Maybe that was the place I didn't search and replace. All right, does that at least get you a pattern? Okay, so we're not blending. That doesn't have visual consistency between levels. Yeah, I'm not able to get visual consistency right now. So something at the way I'm striding through this is not... Well, those are consistent. Oh, this is the point where it's just zooming stuff. So I think from the other, some of the patterns I saw, this is about right. And we now have a means to play around with, to some extent, things like, what does that do? Ew. Oh, you can see the interpolation now. Yeah, so that's all messed up. Okay, well, that doesn't work well. Oh, so maybe it's the blending that creates the darkness. I mean, there was still a lot of darkness. That does create larger patterns, but also very dark patterns. And then scale. I think for Crucible, they essentially just moved everything up one. Yeah, so I think this is supposed to be scaled such that the peaks are like one biome. So you run this once for each layer and then check which one is the highest. But the way I'm iterating through my strides is not... The way I'm translating coordinates is not correct here. Oh, wow, you can really see some of the interpolations as strong lines there from the blend. Ooh, yeah, I might have to look into some of the other advanced rendering techniques because you can see a little bit of a hitch there. Yeah, so it is not responding correctly to scale. So I may have to get to find the output biome fractal function. So I don't know if this stride is correctly, because it could just be changing coordinates, and it seemed to work fine for the regular old plain old biome. Oh, or maybe I'm not even setting my start coordinate correctly. So for that, I really want to pay attention to 0. We've gotten way... Man, the gradical does not show up on this. Okay, I can start seeing the patterns. I think Zoom 24 is where it's, so to speak, real. Oh, 7 is a particular biome. No, it's number of biomes, and then we use different seeds for the different layers. That seems like about maybe the right scale. Okay, those are consistent, but not really. Well, maybe that's that pattern drifting down. Yeah, so this might just be a coordinate calculation issue. So for this, what we really care about is not as much that as... Actually, why am I doing... No, because it's tile coordinates, so we have to... get a point and translate it. Okay, so for 0, 0, right, because the y is inverted, so it actually goes to -1. So, leaflets tile 0, 0 is going to be here. In the game's coordinate system, that start is going to be -1. Oh, we must have started at level 17 and then zoomed in. Okay. So for actual coordinate 0, 0, well, no, it's actually going to be offset. So our start xy, start y is going to be -1. And then we're going to take -1. Well, if individual tiles were flipped, I don't feel like we'd get visual consistency. So as we go up, we're changing our stride. This is one of the things I might need to test with at some point. Output map object image. Output map biome image. So I'm going to get the colors at some point. And so we're just skipping coordinates. And this is iterating over tile size. So this is image space. All right, so we did an experiment earlier, and this is a really expensive calculation, where we did this just to establish our coordinate direction. And I feel like the coordinate direction flipped. Since I was doing this before. Well, okay, so x and y is going to go that way. Right, yeah, we're zooming into the image, and then the tiles are always the same. Now, wx, wy, got some problems. So I guess first we've got to fix that. Oh, it probably doesn't behave well at negatives. For the... Well, no, because the x and y were behaving well for negatives. And this is only one coordinate. Y is continuing to behave well. X has stopped yeah. X has stopped gradiating. Maybe I need to pay more attention to, well, no, we got negative coordinates. Now, the print order here isn't necessarily going to be cooperative. So what we can do is just get one per, say. And I can't even open up the tab to reload it. Okay, now we should have slightly more reasonable output. Well, maybe not. Okay, I mean, it's somewhat responding. We're seeing an odd pixel left over. But I'd expect to see slightly more variation in the numbers there. Just a little bit. Just a little bit. Wait, we saw... Actually, okay, no, there's... U. This should be a 0 to 1. I think my debugger's toast. That looks a little bit better. Okay, so for something like 0, 0, 0, negative 1. 0, negative 1. A very, very, very large number. Oh, this is at scale 17, so that's believable. Right, we didn't have our previous zoom value. Okay, 0, 0, scale 24, 254, 254 is our first thing. If we go to x negative, negative 768, negative 768, negative 0. So why is it only the x? That gets hard cut down to, well, I kind of need to have middle values. Because it's pretty, like 7 and 8, huh? All right, 0, 0, scale 24. Okay, so that seems reasonable. Can we see the beginnings of something here? That's a lot more green than red. Right, because it's world X, world Y, so one starting high, one starting low. Yeah, we still got this problem. So as we go out here, X is getting more and more negative. We're not getting any red. Oh, I guess these were still in memory. I guess the polarity of X is fine. Okay, so now we need to be looking at middle values. 127, 127, 128. So that seems correct. Wait. No, yeah, y times width. Height, width. Okay. Oh, it's staying negative. Now, why y isn't staying negative, I don't know. But if I'm going to use these as color values, I need to... Oh, okay, so abs is the wrong function. Why isn't this affecting y? So this is just for the coordinate conversion. Oh no, I guess the inversion is. No. Wait. Why did I thought what? Well, that could explain some of the weirdness. Zero is not zero. All right, so we're doing that wrong. It's hard to see with the tiling. Okay. This is world X, world Y. And we are at zoom 21, 23, 24. Well, we're 0, 0. It's always in the lower part of the screen. So that's more than one tile's worth. Well, okay, we're at a stride now. So whatever we're doing with stride is wrong. I think this is where... That is about 256. Maybe... This just needs to be inverted? It's kind of hard to tell without real data. So there's an odd black line there. Which suggests a hole. that at least seems to be putting world x and world y 0 on the correct plane. And there's probably just like a starting point issue within the tile. It's not really doing good sampling right now. Yeah, because that's world coordinates, so we're always going to crunch down to something. Oh. That's consistent, but also backwards relative to x. Oh, maybe, did I get my multiplication in the wrong spot? Okay, so this one had this entire offset by stride. So that's the world x is running in the wrong. I can see x getting brighter away from 0. We want y to get brighter away from 0. We know. Well, I mean, this is just an offset by one thing. So that has the correct direction in positive, but it's like offset this entire thing. So that was subtracting the entire amount. Oh, we're not on 0. Okay, so that is 24 is fine. 23 is not fine. So the direction about it 0 is correct. The offset is not. That looks more wrong. That's like doubly wrong. It's wrong in the other way. It's like flipped polarity. Maybe I just need to calculate it. Actually, I guess the variation of this is just calculating a different corner. I thought so if we take x and y, regular x and y, then they are increasing downward. So if I calculate the northwest corner, that is going to be the 0, 0 of that x and y. For a point that's not at 0, we're going to calculate the world coordinates of that. And then x will be able to stride across this way. We'll have the world coordinates at the top of this. And as we increase that y, we will need to decrease start. And start y should be fine. It just has to be updated properly. So start y is going to start at the top. As we go down, we are going to subtract y from it. I did need the offset for the other biome function. So we're still graphing that stuff. Okay, so that gets our inflection points at the right spot at least, with the way the abs is treating this. And the inflection points don't move around as we change scales and scroll. Okay, that has visual consistency. It also seems to be quite expensive to process, which is kind of what I was afraid of, but maybe I could do some kind of, well, it's the current grid layer, which I'm relying whatever kind of caching it does. There's also the background web worker implementation, which strangely enough was for generating fractals. All right, you know, I never did a checkpoint when I just had bn implemented. All right, do we have anything obviously temporary debugging here? Probably don't want that. This is going to be a per tile thing. That's kind of actually that might be part of the expense we're getting. I turned this off to try and get rid of that influence. Yep, did I save? I did not save yet. Okay, so we don't have that stuff. It's still a little choppy when it has to do a lot of stuff at once. Okay, that's all the obvious debugging stuff. Yeah, I should have checkpointed at BN. Single fractal that remains consistent at scale. Now, to actually do this, the rest of this is going to be complicated game logic. So we've got a biome DB there. So we have get biome index. Oh no, that's the other function. DB biome, that's DB biome. Yeah, compute map biome index. So plus there's all this logic. So there's caching stuff. There's a first and a second place over a bunch of fractals. Oh, compute XY cache hash. It's biome cache. Biome cache record. Yeah, so there's a little bit of stuff to go through still. I mean, see, that's just the cache key. I wanted the well, okay, that's a cache record. Yeah, so there's a little bit of stuff to get through. Biome get cached. Biome cache. So you actually not equal else. Yeah, biome times some stuff, get XY fractal. We're going through the number of biomes and doing one fractal for each. And then we're keeping our first and our second place. So that might be the base level function. But I'm like really late for lunch. I guess to a certain extent, even having any kind of visible fractal is pretty good for the first day, even though I went a little bit late. This is a interesting little line here. Well, people have said they see, actually now that I've got this working, I'm a little bit curious about some of the missing parameters, but I think there's still going to be some gridding because of the way the scale works. Anyway, I'm just going for emulation. That is it for now. Thanks for watching. Thanks to everybody who hosted me. And Sourcegoot, thank you for the follow. Glad you like watching me end stream. It is a little bit later. Well, I'm usually wrapping up about this time. Or, speaking of which, a little bit earlier than this time. Was a bit caught up in that. what else do we got? Let's see, let's select modeling. Becoming a dev is working on stuff. He's like, kind of learning on stream. And the last time I was there, I don't see the message now. He had follower chat on, so maybe that was a temporary thing. But if there's someplace cool to hang out, thanks for hanging out with me. Goodbye, and until next time.